at Southwell Middle School, and today I'm going to be walking you through 4 very important math skills. First, we're going to talk about dividing mixed numbers, then addition and subtraction with decimals, followed by multiplication with decimals, and finally division with decimals.
Today, you'll probably need to understand these vocabulary words in order to be successful. Quotient, the answer to a division problem equation. Product, the answer to a multiplication problem equation. Sum, the answer to an addition problem equation. Difference, the answer to a subtraction problem equation. Whole number, positive numbers, including 0, without any decimal or fractional parts. Mixed number, a number made up of a whole number that is not 0 and a fraction. Reciprocal, one of 2 numbers whose product is 1. Inverse operation, operations that undo each other, addition and subtraction, or multiplication and division. In simplest form, a fraction is in simplest form when the numerator and denominator have no common factors other than 1.
Before we begin to work division problems with mixed numbers, I'd like you to review a few skills with me that you're going to need in your toolbox to be successful. The first skill that you will need to be comfortable with is multiplication of fractions. To multiply a fraction, we need to first make sure that everything's written in an a over b times a over b form, just like this. Now that we have our problem set up in the correct format, we can then multiply the numerators, multiply the denominators, and then combine those into our new fraction. Of course, we need to make sure that we simplify our answer. For example, let's look at 1/3 times 3/4. It's already been written in AB format, so we multiply the numerators, 1 times 3, multiply the denominators, 3 times 4, and we get that our product is 3/12. Now I know that 3 and 12 share a factor of 3, so I can simplify this by dividing by 3. And that gives me my new simplified fraction, 1/4. The second skill that you'll need to know how to use is how to convert a mixed number into an improper fraction. So first, remember that a mixed number is the combination of a whole number and a fractional part. An improper fraction, on the other hand, is where we have a fraction where the numerator is greater than the denominator. For example, let's look at an easy one. Let's just look at 1 1/2. To turn this mixed number into a fraction that's in our AB form, we would first multiply the whole number times the 2 in the denominator. This represents how many fractional parts make up that whole. So 1 times 2 is 2. Then we need to add the 1/2 that was already there in our problem. So we have 2 plus 1, and that tells us that we now have really 3 pieces that are 1/2 size. The third skill that you're going to need to be comfortable with is the use of a fraction's reciprocal. As the vocabulary section slide stated, a reciprocal is one of 2 numbers whose product is 1. In simple terms, the reciprocal of any fraction is simply where you switch the values of the numerator and the denominator. For us today, that's going to allow us to turn our division problem into a multiplication problem, which we can solve more easily. For example, 2/3 would just become 3/2 if we were looking at its reciprocal. Now that we've covered all the prerequisite skills in order to do division with mixed numbers, I want to go ahead and solve an example problem for you, and then that way you can use that to help you with your actual work. So for example, let's try to solve 3 2/3 divided by 1 1/5. Our first step is to convert both of these mixed numbers to improper fractions. For 3 2/3, we're going to multiply the 3, the whole number, times the 3 denominator, which is 9, and then add the 2. And that gives us our improper fraction 11/3. We're going to follow the same steps for 1 1/5. 1 times 5 is 5. Add the 1, and we now have 6/5. Our two fractions are in AB form, but in order to actually solve this, we're going to need to use the second fraction's reciprocal. This will let us change it to a multiplication problem. The 11/3 stays the same. The 6/5 becomes 5/6. And now let's change it to a multiplication problem, which we can solve. We simply multiply the numerators. 11 times 5, 55. Then multiply the denominators. 3 times 6 is 18. Now right now my answer is set up as an improper fraction, so we're going to go ahead and simplify that to a mixed number. To do that, I'm going to divide the 55, the numerator, by the denominator and see what fractional parts are left over. Times 3 times 18 is 54, which means we have a remainder 1. Our 3 is our whole number, our 1 is our numerator, and 18, our divisor, becomes our denominator. 11/3 divided by 6/5 equals 3 and 1/18.
Two numbers are reciprocals if their product is 1. 7/3 and 3/7 are reciprocals because 7/3 times 3/7 equals 1. Write a mixed number as an improper fraction to find its reciprocal. 2 3/4 and 4/11 are reciprocals because 2 3/4 equals 11/4, and 11/4 times 4/11 equals 1. To find 2 3/4 divided by 1 3/4, first rewrite the mixed numbers as improper fractions. 11/4 divided by 7/4. Next, rewrite the expression as a multiplication expression and replace the divisor with its reciprocal. Solve. Write your answer in simplest form.
Now we're going to move on to adding and subtracting decimals. When it comes to adding and subtracting decimals, I typically remind my students to think of our money system. If you're trying to figure out how much money you had from a pile of dimes and a pile of pennies, you're not just going to count the individual coins and say that that number of coins is your actual amount. Instead, you would count how many dimes you have and then how many pennies you have, add up those totals to come up with your actual value. In the same way, when it comes to adding or subtracting decimals, even if they have whole number parts, it's the same skills that we've been working on. We just have to remember our place value. For example, let's look at 2 8/10 plus 1 1/10. Notice that I wrote my addition equation vertically, and I made sure that I had my decimal place lined up. My 8 that was in the 10th place and my 1 that was in the 10th place are over top each other. My whole numbers are also lined up based off their place value. After that, it's just simple addition. 8 plus 1 is 9. 2 plus 1 is 3. That gives us our answer as 3 9/10. Make sure you bring this decimal down in the exact same location as it is above. It's the same thing as saying I have 2 $1 bills and 8 dimes, plus I have a $1 bill and 1 more dime. How much money do I have? Well, you have 3 $1 bills, and then you have 9 dimes. When it comes to working subtraction problems with decimals, it's essentially the same thing as addition. As long as you have your decimal places lined up, and your numbers are in the proper order in terms of their place value, it's regular subtraction. So if we look at the same numbers from earlier, 2 8/10, but this time we do subtraction with that 1 1/10, they would line up the exact same way. we would simply subtract. 8 minus 1 is 7. 2 minus 1 is 1. Bring down that decimal so it's in the exact same place. If you're struggling with this skill, I would suggest maybe drawing a quick grid, and this way you can just line up your numbers based off their place value, but that's completely up to you.
You can use a place value chart to help you add and subtract decimals. For these two examples, they created a place value chart to help them with their work.
We're now going to move on to multiplying decimals. You're going to notice the text examples on the next slide use a 10 by 10 grid to help you multiply decimals. Personally, this is not my preferred manner to teach this skill. Instead, I want to show you how to solve these problems with the use of the standard algorithm. To help build understanding for why this skill works, I'm going to use a number of related problems where only one aspect of the place value is being changed between each one. For example, look at the problem 12 times 9. Now this is a math fact, so I should know my answer is 108, but just in case, 2 times 9 is 18, 1 times 9 is 9, plus that carried 1 would give you 10. Now if we look at a similar problem, 1 and 2 tenths times 9, you're going to notice we now have a number behind the decimal on the top part of our multiplication sentence. We're going to bring that back at the end, but at first we just get to solve this as if it was a normal multiplication problem. 2 times 9 is 18, carry the 1, 1 times 9 is 9, plus 1 is 10. Now here's where that decimal comes in handy. We're going to use that to help us figure out what our actual answer should be. Because there's one number behind the decimal place on the top, there needs to be one number behind the decimal place on the bottom. The digits are the same, but because we've really divided that one by a 10, we need to make sure our answer has been divided by a 10. Just jump the decimal. If you look at our third example, once again, same numbers, except now we have 2 digits behind the decimal place. That means in our answer, we're going to need to have 2 digits behind the decimal. 1, 2. First though, solve it like a regular multiplication problem. 2 times 9 is 18. 1 times 9 is 9, plus 1 is 10. Add a place value holder, everything times 0. Combine your partial products. And here's where we need to bring back the decimal. One number behind the decimal, 2 numbers behind the decimal, 1, 2, 1 and 800ths. Notice all 3 of these problems have the same digits. They have the same 1, 0, and 8. But the place value for them has to be changed based off the place value for what we're actually multiplying.
You can also use a model to help you multiply a decimal by a whole number. Notice in the model for example 1, they shaded 4 groups of 12 blocks, where each block represented 1/100th. Then, they simply counted to find the total would be 48/100ths. For the second example, they did a multiplication by 2 decimals. So first they shaded 8/10ths of the figure, or 80 of the squares. Then they shaded 4/10ths of the shaded area darker. They would simply count the number of squares that were shaded to figure out the new product.
Similar to multiplication, the division examples from the text use a 10 by 10 grid for one of the methods, and then they actually use the standard algorithm for the second. I prefer to teach the second method that's being presented. What they are doing is, by multiplying both pieces of your division problem by a factor of 10, you're going to be able to use the standard division steps to solve any of these problems. For example, I want to look at solving 3600ths divided by 3/10. First, we're going to write our dividend, 3600ths, inside. We're going to write our divisor, 3/10 on the outside. To turn our divisor into a whole number, for this example, we need to multiply it by 10, or jump it once. Now, whatever we do on the outside, or to the divisor, we need to also do to our dividend. So I need to multiply this by 10. Same as just jumping the decimal, one place value. Now, because I've multiplied these both by a value of 10, I can go ahead and solve my new problem, 3 6/10 divided by 3. We could solve this as the same way we do any division problem. Dividing across place values, 0 is divided by 3 0 times. 3 divided by 3 is once. Multiply, 1 times 3 is 3. Subtract, 3 minus 3 is 0. Bring down the remaining 6. 6 divided by 3 is 2. Multiply, 2 times 3 is 6. Subtract to see if you have a remainder. You don't for this example, so our problem is done, except for one final step. The last thing we need to do is, we need to move our new decimal place back up to our quotient. This is showing us that 3 6/10 divided by 3 is going to give us the same quotient as 3600ths divided by 3/10. All we've done is change the place value for both pieces of that equation to make it easier to solve. We haven't actually changed the value of any parts of that.
In the text examples, you'll notice that they use that 10 by 10 grid that I mentioned. For the first, they shaded in 3500ths of the grid and then circled groups of 7. For the second example, which is my preferred method, they used the standard algorithm where they made sure to convert whatever we were dividing by into a whole number and then to compensate with your second number. Thank you for joining me today. If you have any questions about this lesson, please email me at joe.peden@knoxschools.org. Remember to stay safe, stay healthy, and your teachers miss you so much, y'all. Have a great summer.